Hello.
Yes, teacher. Afternoon.
Good afternoon to you. We want to start from where we stopped in the morning in this afternoon lesson, and we see what comes next. In the morning, we ended up showing, or we ended up when we are looking at evidences, all evidences of natural selection in action, evidences of natural selection. We stopped looking at evidences of what? Of natural selection. And those evidences, we said there are four. There are four, into which what we call natural selection in action or evidences. We said there are four. One, we said the polymorphism. Polymorphism. Two, we said pesticide, comma, either you can call it pesticide or insecticide or drug or antibiotic resistance. That is the second one. Then the third one, we said heavy metal tolerance, and the fourth one, we said industrial melanism. We described the polymorphism. We said the polymorphism is the existence of an organism, or is the existence of organisms of the same species in two or more different structural forms. And we said we have very many examples here. We can look at blood group, sickle cell, sex, many things, color blindness, very many things, drone and queen bees, all of those, that is sex. We said we can use peppered moth. We said there are those examples of snails, where we have the brown, the yellow, and the pink. Those are some of the examples we gave. But we said polymorphism, the word poly means many, and morphis means structure. Therefore, here we shall have existence of two or more forms of organisms of the same species in different forms. We say there are two types of polymorphism: balanced. If you don't call it balanced, you can call it stable. If you don't call it balanced, you can call it stable. And we said this is the existence of organisms. This is the existence of organisms of the same species in two or more different forms, but in a consistent form, in a constant form. Like sex, like in sex, when you look at an example of sex, male and female, none of them is rapidly increasing and none of them is rapidly decreasing. All of them are in a constant form. Then we looked at transit, which we called either transit or unstable, which is a type of polymorphism whereby two or more different organisms exist in different forms, but whereby one organism is increasing in number and another one decreasing in number. Like the most common example used here, we use the melanic form of peppered moth and the non-melanic form. The melanic is the dark one, the non is the light one. That during Industrial Revolution, those industries in England those industries released smoke which contained soot and contained sulfur dioxide. These two made the barks of the tree become black, paint them black. Therefore, the light peppered moth, or which we call the non-melanic peppered moth, would no longer be able to camouflage. Therefore, a mutation occurred into it, leading to the rise of a new form of peppered moth, which we said, which is black. And due to black, because the barks of the tree were painted black, this melanic form, its population increased rapidly, meaning it was selected for it would easily camouflage against predators, and its population increased in the following years, while that of the gray, the non-melanic peppered moth, decreased because it would not now camouflage. Therefore, it was selected against. Therefore, that is what we talked about under transit, or what we refer to as unstable, the existence of organisms of the same species in two or more forms, in two or more forms in a population, in which one form, which is better adapted, increases in number, while the poorly adapted individual population decrease. That is what we talked about. Then from there, we went to what we call industrial melanism. We said industrial melanism is a process, is evolutionary process, whereby we said we are looking at what we refer to as industrial melanism, and we said industrial melanism is an evolutionary process that resulted into increase in the frequency of the melanic type of peppered moth more than the light type, because the melanic type had a selective advantage and the light moth was selected against due to industrial revolution, which brought about the painting or making the barks of the tree the barks of tree dark. That is what we looked at, and you'll read it through. And we said this industrial melanism occurs by mutation. It is because of mutation we got the black or the dark moth, because after industrial revolution the light peppered moth started being selected against, because it would easily be predated on by its predators. Now, due to mutation, as years went on, due to mutation, gave rise to a black or a dark peppered moth, which had a selective advantage, and therefore for their population increased, and this one decreased with the time. That is what we call, hence leading to evolution. That is natural selection in action, because one of the peppered moth, the melanic one, was selected for because it had favorable characteristics of camouflaging. Therefore, that is what we talk about, or what we mean by industrial melanism. From there, we looked at what we call either drug, pesticide, antibiotic, or insecticide resistance. We said that these pathogens or bacteria or these germs can get adapted to drugs. The insects can get adapted to insecticides. The pests can get adapted to pesticides. The biotics can get adapted to antibiotics. Therefore, in this case, that's why we call it resistance. They become resistant to those drugs. In this case, we said, what is drug resistance? We said drug resistance is whereby the mutant type of pathogen develops resistance. It means also drug, it means also this, what we refer to as, it means also the drug, what we refer to as drug resistance, what we refer to as drug resistance also arises as mutation. Therefore, you cannot talk about drug resistance without talking about mutation, because it is the one which will bring about the mutant. When I say a mutant, I mean that species which has been developed, which has rose as a result of mutation. Therefore, in this case, when we talk about drug resistance, this is whereby a mutant type or a mutant strain develops resistance towards a drug which failed to kill it in a normal way. I gave you an example of Plasmodium. I gave you an example of a Plasmodium. Plasmodium. I gave you an example of Plasmodium. In this case, Plasmodium causes malaria. We said earlier, for us, by the time we are still young, playing in the rain, those years, we would use some different drugs like chloroquine, fancida to treat malaria. But due to this Plasmodium parasite getting adapted by mutation or going under mutation, we formed a mutant strain of Plasmodium, which now cannot be killed by the drugs, that is chloroquine and fancida. Chloroquine and fancida. That's why doctors and different medics developed new drugs of what? Of malaria, Watam, and so on. Those ones now these days you buy. But it rises as a result of mutation. You'll soon know what is mutation and how mutation causes this. Mutation is change in the gene structure. Now, when mutation occurs in these pathogens, they obtain an enzyme we call oxidoreductase enzyme, which this enzyme will render the drug less harmful, will oxidize the drug or reduce the drug in any way. Therefore, it can no longer kill the pathogen, in this case, the Plasmodium. That's what we refer to as drug resistance. This is whereby the mutant type of pathogen develops resistance towards antibiotics, which fail to kill it in a normal way. And by the time we are going, I had given a question saying, explain how antibiotic resistance or drug resistance arises. According to me, I can read through my answer I wrote as you're doing others. Me, what I wrote, I said resistance occurs by mutation. That is a mark. That is what you have to first tell me. You cannot talk about resistance, how it arises in organisms, without talking about mutation, because mutation is the one which is going to bring about the other strain, the type of an organism which can no longer be killed by the drug. Therefore, mutation, resistance occurs by mutation, producing a mutant strain. Which mutant strain contains or produces an enzyme which we call oxidoreductase enzyme. That enzyme, oxidoreductase enzyme, deactivates or breaks down the drug. Either someone can say deactivates or breaks or oxidizes or reduces down the drug, therefore becoming resistance. Therefore, exposure of the same drug to the mutant strain will no longer affect it. But exposure of drug to the non-mutant, that one which did not mutate, non-mutant strain, will result to its death. It means those organisms, those pathogens which have not, those organisms which have not mutated, will, for them, they will die. And now we shall have only those ones which have mutated, develop, reproducing. It means the mutant will be selected for, and the non-mutant will be selected against. That is a natural selection. Therefore, that is drug, what we call drug resistance. It's where we stopped. We stopped on that third example or evidence of natural selection. Now, the last one is what we call heavy metal. We call it heavy metal tolerance. Heavy metal tolerance. We have heavy metals. You know metals in chemistry. An example of a metal, we have silver, we have mercury. Those are heavy metals. Those heavy metals, silver, mercury, tend to kill plants. That's why when that's why they tell you that when you get these heavy metals and you pour them somewhere, like mercury, like silver, and you pour mercury somewhere, all plants there will die because these are heavy metals. But some plants have become tolerant to them. Therefore, when we talk about heavy, when we talk about heavy metal tolerance, we shall find out that heavy metal tolerance, this is a conditional, this is whereby some certain grasses have developed tolerance to heavy metals such as copper, zinc, lead, silver, mercury, and therefore they can survive in soils which possess these heavy metals. Their population is higher than those grasses which are not tolerant. Therefore, here in this case, heavy metal tolerance, we have two types of grasses. We have those ones which are tolerant, those ones which we can say these grasses are tolerant, and those ones which are not tolerant or non-tolerant. Therefore, the tolerant grass are able to withstand these heavy metals and grow. Therefore, they are better adapted. They are better adapted. They have enzymes which can break them down and render them non-harmful to them. But the non-tolerant ones will fail to grow. They will fail to grow. Therefore, the population of the tolerant grass will be higher than the population. The population of the tolerant grass will go on increasing because it has a selective advantage, while the population of a non-tolerant will go on decreasing because it has a selective disadvantage. It will be selected against, and when it is selected against its population, therefore it cannot mature to a reproductive age, and therefore its population cannot multiply. You know, one mechanism by which the population of organisms keep on increasing is through reproduction. And anything which cannot reproduce, it means its population will decrease because organisms will die. Some organisms in the population will die. Therefore, if they are not reproducing to replace those ones which are dying, therefore their population goes on decreasing until they get extinct. Therefore, we remain with only that species which has been tolerant. Those are the evidences of evolution of natural selection. Any question? Any question? I don't need a question saying, Master, what you taught, I was not there in the morning. I am seeing some members here who were not here in the morning. I need questions which are concerning what we studied. If you have gone through that work, have you got any challenge? I'm seeing the hand up here. by my friend Caroline. Yes? I'm hearing Caroline.
Teacher,
Talk loudly.
teacher, what is that feature?
What?
Yes, teacher, what is that feature that enables these tolerant plants to survive
There
in
are very
presence
many
of the heavy
features.
metals?
There are very many features they can possess. One, they can have enzymes which can break down those metals. They develop new synthetic systems. Like these heavy metals have a tendency to block processes like photosynthesis, to block processes like respiration. Therefore, the plant cannot respire. And when it cannot respire, it can no longer grow, because you know the role of respiration in growth. Therefore, these plants, those ones which are tolerant, get enzymes which can avoid, which can no longer be affected by these heavy metals. Their enzymes get adapted, or these organisms form new enzymes, or these plants get new enzymes. Therefore, they may not ask you how heavy metal tolerance arises, but what you must know, it arises also as mutation, giving giving tolerant plants, and those ones, therefore, their population increases because they will reproduce, and the non-tolerant will fail to mature. Therefore, their population decreases. They will be selected against. Any other question? If no question, I'm free to move on. Now, remember, when we are starting this natural selection, we first defined it, we first gave a definition of selection. We said the selection is a process, is evolutionary process, which determines the survival of an organism. Is evolutionary process where an individual, an organism with favorable characteristics are allowed to survive, while those ones with unfavorable features die and get eliminated. That's what we call selection. Therefore, we divide the population into two. Those ones which have favorable characteristics, that is what we call selection, and those ones which have unfavorable characteristics. Favorable and unfavorable. The favorable will interbreed to reproduce and pass on their genes to the next generation, but these ones will die. It means we are getting a new species here. Therefore, that is what we call selection. But we say the selection, we have very many types of selections. The first type of selection we said is natural selection, and all along we have been looking at natural selection. Here we defined it. We said natural selection is a mechanism of evolution. We said natural selection is a mechanism of evolution where organisms with favorable characteristics reproduce, and it is done naturally by the environment. It's done naturally by the environment. That is what we refer to as natural selection. Nature does it, selects. The selection pressures in the environment. Selection pressures, we said, when we talk about selection pressure, is a particular factor in the environment. So those natural factors, therefore this is natural. That one we have finished it. We looked at what is natural selection. We looked at types of natural selection. We looked at natural selection in the action. Very many things we looked under here. Now, another type of selection, we have other types of selection, not only natural selection. Another type of selection is what we refer to as artificial. You have been hearing this, artificial selection. The other one is natural, but this one is artificial selection. Therefore, someone can ask you, what is artificial selection? Or the question can come and say, hey, state different forms of natural selection. State different forms of selection. State different forms of selection. State different forms of selection. They will say state different forms of selection. Someone can say, hey, what is natural selection? No, what is selection? You tell him selection is, when we talk about selection, we have already defined it by saying selection is evolutionary process where individuals or organisms with favorable futures in a population survive to interbreed, while those ones they fail, others with unfavorable fail. Now, types, one of them, types, examples, we have natural selection. Now we have on artificial. What is artificial selection? This one is done by the environment on its own, nature. But this one, since it is artificial, therefore it involves man or human being. Human being. Therefore, when we talk about artificial natural selection, is the type of selection, is the type of selection, or is selection breeding, is the type of selection which involve selective breeding. Therefore, here we have selective breeding of organisms, showing characteristics which are desirable, characteristics which are desirable to human being. You sit there, you see a bull and say, this one, I will breed this. You do selective breeding. Therefore, what makes up artificial selection is selective breeding. Selective breeding of what? Of organisms. Which organisms? Those organisms with desirable characteristics to you. Therefore, this does not involve nature. This is man doing it through selective what? Through selective breeding. Have you understood what is artificial? Therefore, the difference between natural and artificial, this one artificial involves man, but natural does not involve man. Any question? Any question? Now, after understanding what is artificial selection, like good meat, high milk production, resistance to drought, resistance to diseases, high egg production when it comes to poultry, quality of wool when it comes to sheep, good racing ability in horse. When you go to people who rear up these horses, they will only rear those ones which are good at running. The weak ones will not. They will only interbreed. No one will like a bull which has poor meat. Therefore, here, those are examples of artificial selection. Such desirable characteristics which are desired by human beings, even in you. Therefore, that is what we refer to as artificial selection. Males and females possessing desirable characteristics are selected. We only select males and females with their desirable characteristics. You take your cow to a bull with only. In your farm, you will not sell cows with good milk production, which are good to meat production. You only sell those ones which give you less milk. Altogether. But artificial selection has two types. Types of artificial selection. Artificial selection. Types of artificial selection. One, we have inbreeding. And two, outbreeding. These are simple things you have been hearing. Biologically, what is inbreeding? What is inbreeding? Roman 1, we are looking at inbreeding. Who can tell me the definition of inbreeding? Who can tell me the process of inbreeding? What is inbreeding? Inbreeding, who? I'm waiting for the hand here. I'm not seeing anyone. Inbreeding.
Teacher, it is the breeding between closely related individuals.
Therefore, here in what makes inbreeding? In your definition, there must be closely related individuals. Closely related individuals. Therefore, here in inbreeding, we select. This is the selective mating. Because already we have said in artificial selection, we have selective breeding. Now here we have selective mating of closely related individuals, e.g. self-fertilization. Self-fertilization, like self-fertilization in plants, which you call self-pollination. 2, crossing of offsprings of the same parents. Crossing offsprings of the same parents, that is in inbreeding. Therefore, in inbreeding, it involves selective mating of closely related individuals. Now go and find disadvantages and advantages of inbreeding and outbreeding. I'm not going to talk about that because there is another topic which will emphasize that is reproduction. Then Roman 2, another form of artificial is outbreeding. What is outbreeding? Who can tell me outbreeding is? Like how Ndagire told us. Now we need someone to tell us what is outbreeding. This one we breed or we mate closely related individuals, but in outbreeding, what happens? Here we have mating, selective mating. We have selective mating of unrelated, all, someone can say, not genetically closely related individuals. Therefore, here we selectively, there is selective mating, there is selective mating of unrelated individuals, all not genetically closely related individuals. E.g., an example, cross-fertilization. Like you get a local breed of a cow and you cross it with a Frisian bull. That is cross-breeding, outbreeding. Unrelated individuals. You get a Muganda and a Muganda marries an Arab. That is outbreeding because they are not related genetically. Therefore, in that case, those are the two types of artificial selection. Now, someone will say, explain how artificial selection supports evolution. Are we hearing questions? Explain how artificial selection. Explain, let me write it here. Explain how artificial selection supports, or you can say leads to evolution. Artificial selection. How does artificial selection lead to evolution? First of all, what you have to tell him that, or the examiner in this question, you have to first tell him that artificial selection by man, by human being, or man, human being, because it is by human being. That you'll have a tick there. Exerts, because all this brings about anything which is to bring evolution must exert a selection pressure. Everything. There cannot be evolution without exerting selection pressure, either naturally by the environment or by man. But this one is going to be exerted by man. Therefore, artificial selection by man. Artificial selection by man exerts, by human being exerts what we call direction. Now, this one, if someone remember what we call directional selection pressure, we say the directional selection pressure is the type of selection pressure, or is the type of selection which exerts, which does what? Which is exerted on one phenotype, favoring another one on another extreme. Therefore, this one exerts what we call directional selection pressure. Like if you have two bulls, one which grows fast and another one which grows slowly, man will select this one which is growing fast and interbreed it many times. Every time keep on interbreeding it, giving it chance to mate, while the other one will not be given chance to mate. Now the population of these bulls will go on increasing because they are reproducing, while these ones which are not growing fast will be selected against. They go on reducing, this one is increasing. Therefore, direction, this one brings up, because we exerting selection pressure on one extreme, which is poor growing slowly, and favoring this one. Therefore, the mean shifts towards this one which is growing fast, because for them they are given a chance to reproduce. Therefore, that's how artificial selection supports evolution, because artificial selection by man will exert directional selection pressure